Hello, college algebra, and welcome to our lesson over 4.4, the fundamental theorem of algebra. First things first, I want to do a quick warm-up where we're going to determine the y-intercepts of the following function. And of course, if you remember how to find y-intercepts from previous lessons, the hint is that for any y-intercept, its opposite value x will always be 0. So with that in mind, why don't we take the fact that x is equal to 0 and let's plug that in for each x value that we have here. So in other words, that'll become 0 minus 1, 0 minus 2, 0 minus 3. And of course, if we go ahead and do that part of the math, 0 minus 1 becomes negative 1, 0 minus 2 becomes negative 2, 0 minus 3 is negative 3. So you have negative 1, negative 2, negative 3. But of course, when they're all in parentheses like that, you can assume that you'll have to multiply all those numbers together. So negative 1 times negative 2 times negative 3 should give you negative 6. And this will be your y-intercept. But remember, for the Hawks program, it'll want that y-intercept as an ordered pair, so 0, negative 6, where your x is always 0, and your y is the other value. And that's what you would put into the Hawks program when it asks you for the y-intercept. So that was a quick warm-up. We will be doing a couple more problems like this where you'll have to find the y-intercept, and now you will feel more comfortable about those problems when they come up. So with that said, warm-up done. Now let's move on to the main topic of today. So if you have a linear factor and it appears m times in the factorization of a polynomial, then C is a 0 or x-intercept of multiplicity m. Okay, at first, that's a lot of words to take in, so if you didn't quite understand that sentence, that's okay. Let me explain that sentence with some examples. So, if you look at this first example, you have x plus 1 as a factor, and then it's raised to the power of 3. This particular equation is going to tell us two things. It's going to tell us what the x-intercept is. And your x-intercept is going to be negative 1. Because with all factors, to find your x-intercepts, you always set the factor equal to 0, and then you solve. And that's how you get that your x-intercept is negative 1. Now that's the first thing that this equation tells us. The second thing this equation tells us is its multiplicity. And specifically, its multiplicity is determined by the power. Or in other words, the multiplicity is 3. And the reason why we call it multiplicity is because if you think about it, x plus 1 is being multiplied by itself 3 times. Thus, that's why we say multiplicity of 3, because the power of 3 is the same thing as multiplying by the factor as many times as the power. So now that you know the definition of multiplicity, this will make a bit more sense. Now, let's look at the other two examples. So let's look at this one. We're going to determine two things. The x-intercept, which in this case, if you take your factor of x minus 5, set it equal to 0, you will get that your x-intercept will be positive 5. And then next step, your multiplicity. And your multiplicity, again, is always determined by the power. Or in this case, your multiplicity will be 4 for this example. And then, for the bottom equation, doesn't look like it has a power or a multiplicity, but it does actually. Its power or multiplicity is the invisible 1. So just wanted to point that out if you did not see that. I'm sure most of you already saw that, but just in case. So x-intercept is going to be -2. Again, basically going to be the opposite of that number. And then last but not least, its multiplicity is going to be your power, or in this case, the invisible 1. So now that we've gone over those examples, this definition may make more sense. Multiplicity of m, or this power, represents how many times your factor is being multiplied. And of course, your x-intercept will always basically be the opposite of your factor. As long as you get the hang of that, then this, oh my gosh, if you understand that, then this lesson should actually be pretty easy, pretty straightforward, and pretty fast. So with that said, now moving on to the second topic of today's lesson is the the geometric or graph meaning of multiplicity. Or in other words, you now know what multiplicity is, but what does that mean if you were to graph an equation that had multiplicity like this? Now, when it comes to graphing these type of equations, there's 3 main components. And you will definitely need to make sure you have these 3 components memorized, or at least written on a separate sheet of paper so you can look back to these 3 key points in this lesson. Key point number 1, if your m, or your multiplicity, is greater than 1, then the graph of your function will flatten out near your x-intercept. And I will explain what that means on the next slide. But I'm just going to go over the key components. That was key component number 1. Key point number 2, your graph will cross through the x-axis if your m, or multiplicity, is odd. Again, I don't expect you to memorize that right now, but write it down on a separate sheet of paper because you will need to look at that later. Step or key point number 3, your graph will stay on the same side of the x-axis if m, or your multiplicity, is even. Again, I don't expect you to memorize all 3 of these key components right now, but for the time being, have each of these written on a separate sheet of paper. Keep those handy. You will need those for the rest of the slide. Go ahead and pause the video for now, write these 3 components on a separate sheet, and then resume the video. Okay, you should have these components written down on a separate sheet of paper. Now let's move on. So, here I have 2 examples of equations that have multiplicities, and I want to talk about each one. Let's take a look at the one on the left. If you look back to those 3 key points, according to the first one, our multiplicity is greater than 1. Because our multiplicity is 3. Since it's greater than 1, that means that this graph is supposed to flatten out near the x-intercept. And sure enough, at our x-intercept of -1, our graph does tend to get a bit more flat right at that point. And then, according to key point number 2, since our multiplicity m is odd, that means that our graph is supposed to cross the x-axis. And sure enough, it does indeed cross the x-axis right at our x-intercept. And of course, key point number 3 doesn't apply here because our m is not even. So moving on to graph number 2. Here we have g of x is equal to x plus 2, all to the power of 4. According to key point number 1, the multiplicity of 4 is greater than 1, which means our graph should flatten out at our x-intercept. And sure enough, at our x-intercept of -2, our graph does appear to get a bit more flat right at that area. And then, according to key point number 3, since our m is even, that means our graph should have stayed on the same side of the x-axis. And sure enough, notice how this graph didn't exactly go across to the opposite side of the x-axis. Instead, it made a U-turn, like touched it and then turned. Touched, it did touch the x-axis, but it did not go across it. And that's what it means by stay on the same side. It basically just took a U-turn. So now that you understand, basically, these two examples were to better explain what the 3 key points meant in terms of these equations. But luckily for you guys, you will not have to graph these equations. All you have to do is point out the properties of them. And I will explain that in a couple examples. So with that said, let's move on to our first example. We are to consider the following polynomial, f of x equal to x plus 1 squared, x minus 3 to the 5th, and then x minus 4. For this part, we are first going to determine the degree and the y-intercept of the ordered pair. So first, let's talk about the degree. Now, I'm betting some of you are looking at that equation and you're probably going to say, oh, I think the degree is 5. Hate to break it to you, that's wrong. The degree of 5 is actually too small. You actually need to find the degree by adding all the multiplicities together. So then when I tell you that, some of you are probably thinking, oh, I got to add the multiplicities together, which means I should have a degree of 7. Some of you are probably thinking that. And once again, you're wrong. Because, of course, 2 plus 5, adding those two multiplicities together equals 7, but there's still one more multiplicity. It was just invisible. So, 2 plus 5 plus 1 gives you the correct degree of 8. Be careful for that invisible 1. I've seen so many kids get the degree problem wrong because they forgot about the invisible 1. Now you know. Okay, so we got our degree of 8. Check. Now, moving on to the y-intercept. I feel like this is deja vu. I think we already know how to find y-intercepts. We did that in our warm-up. In our warm-up, we just said x was 0. So literally all we need to do is plug in 0 for all the x's. So let's do it. Oh, give me a second. So, for our y-intercept, we're going to plug in 0 for the x, so 0 plus 1 to the power of 2, and then 0 minus 3 to the power of 5, and then 0 minus 4 to the power of 1. Simplify from there. 0 plus 1 is 1, still squared. 0 minus 3 is -3, still to the power of 5. And then 0 minus 4 is -4, still to the power of 1. Yes, you still have to keep those powers with it, or keep those multiplicities. Otherwise, you will get an incorrect y-intercept. So continue to simplify from here. 1 squared will give you 1. Negative 3 to the 5th should give you negative 243, and the negative 4 power of 1 is still negative 4. Now, multiply all three of those together, and you should get that your y-intercept is 972. I know what you're thinking. Oh my gosh, can I have a y-intercept that big? And the answer is yes. For these type of examples, you can get a y-intercept that big, and that is totally okay. And just like before, make sure you enter that y-intercept as an ordered pair. They won't always be that big. Sometimes they'll be smaller, but they could also be bigger, just so you know. So there you go. Degree of 8, y-intercept of 0-972. That step, done. Moving on to the next part. Still got the same equation, but now this is our objective. Identify the x-intercepts at which the function flattens out. Okay, this is where you're going to have to look at your key points. Look at the key points on a separate sheet of paper. Where it says flattens out, that's key point number 1. And according to key point number 1, a graph flattens out if m is greater than 1. So, let's take a look at all the multiplicities that are greater than 1. This one has a multiplicity of 2, and that's greater than 1. This one has a multiplicity of 5, which is greater than 1. The last one does not apply. So, we got to take a look at those two parts. So with that in mind, we now know which parts of the factoring flattens out. And now it's our objective to find the x-intercepts. But of course, we know how to find the x-intercepts. The x-intercept of this part is negative 1. And the x-intercept of this factor is positive 3. And just like that, you have your answers. Negative 1, positive 3. And to enter that in the Hawks program, you just have to type in negative 1, 0, 3, 0. Because that's how the Hawks program will want you to have your x-intercepts. And of course, if you're wondering where the 0 came in for the y, well, remember for x-intercepts, their opposite y is always equal to 0. Seriously, that's it. Those are the answers. Negative 1, 0, 3, 0. Done. All right, moving on to the next one. Again, same equation. Now we are going to do something new. Identify the x-intercepts at which the function crosses the x-intercept. Look at your key points. This is key point number 2. Or in other words, we have to look for where our multiplicities are odd. So this one does not count because that multiplicity of 2 is even. This one is an odd multiplicity. And this one, multiplicity of 1, that is an odd multiplicity. So we now know what factors to look for. Go ahead and identify the x-intercepts. For this one, the x-intercept is positive 3. The x-intercept of this one is 4. There you go. 3, 4. Done. Those are your x-intercepts. All that's left for you to do, put them in as ordered pairs, and you're done. That's it. Feeling pretty good now, aren't you? This is pretty easy stuff so far. Now, same equation. Now, we are going to identify the x-intercepts at which the function stays on the same side. Look at your key points. This is key point number 3, where we're looking for when m is even. If you look at your multiplicities, this one doesn't count, this one doesn't count. This is the only one where the multiplicity is even. So, That's the multiplicity we're going to look at. Now let's identify the x-intercepts. And of course, the x-intercept of this one is -1. So just like that, -1, that's your x-intercept. Just put it in as an ordered pair, type it in the Hox program, press submit, done. Piece of cake. Literally, that's it. This is probably one of the fastest lessons in the book. But just to be safe, let's do another example where we have to go through that 4-step procedure. Okay, now I got a new equation. Consider the polynomial f of x is equal to x plus 3, x minus 4 cubed. Okay, first we're going to determine the degree and the y-intercept. First, let's start with the degree. If you said that the degree is 3, you are wrong. Because the invisible 1 strikes again. So in other words, add your multiplicities together, and your degree shall be 4. Be careful for that invisible 1. It might trip you up. Okay, degree 4 done. Y-intercept is step number 2. And just like the bell ringer, for all y-intercepts, its opposite value is equal to 0. So take the 0, plug that in for all the x's. Let's do it. So 0 plus 3 to the power of 1, 0 minus 4 to the power of 3. Simplify from there. Okay, 0 plus 3 is 3. 0 minus 4 is -4 cubed. Simplify from there. This becomes 3, and then -4 cubed is going to be -64. Multiply those two numbers together. -64 times 3 gives you -192. So that is your y-intercept. But don't forget, ordered pair, 0, -192. Type it in the Hox program, done. Easy peasy. Okay, degree and the y-intercept, done. Now moving on to the key points. Same equation. Identify the x-intercepts at which the function flattens out. Look at your key points. This is key point number 1, where your multiplicity has to be greater than 1. So let's look at our multiplicities. This one, that doesn't work. This one, multiplicity of 3 is greater than 1. So we're going to look at that one. So take a look at that factor, find the x-intercepts. And of course, the x-intercept of this one is 4. So 4 is your answer. That's your x-intercept. Just make sure to type it in as an ordered pair. Done. Okay, that's one key point down. Let's look at the next one. Same equation. Identify the x-intercepts at which the function crosses the x-axis. And if you look at crosses, that's key point number 2. What we're looking for when the multiplicity m is odd. So let's take a look. Multiplicity of 1, that is odd. Multiplicity of 3, that is also odd. So we're going to look at both of those factors. Look at both of those factors and find the x-intercepts. X-intercept of this one, -3. X-intercept of this one, +4. There you go. -3, +4. Those are your x-intercepts. Those are your answers. Just make sure to type them in as ordered pairs. And you are done with that part. All right. Feeling pretty good. Feeling pretty awesome. Let's move on to the next key point. Same equation. Identify the x-intercept at which the function stays on the same side. This is key point number 3. We got to look for when the multiplicity is even. Look at this one. That doesn't count. That multiplicity is odd. That doesn't count. So neither of them work. So in other words, none. You do not have any x-intercepts because you do not have any even multiplicities. Done. Whew. That's it. No, seriously, that's 90% of the lesson in a nutshell. The other 10% is on the last two slides. Let's do it. We're almost done. Now, this one, a little bit different, but it still covers the topic of multiplicity. So, for this example, we are constructing a polynomial function with the following properties. We want a polynomial with a third degree. 4 is a 0 of multiplicity 1. Negative 4 is the only other 0, and the leading coefficient equal to 3. Now, some of you are probably looking at this and you maybe feel a little overwhelmed. Don't worry, this is actually a lot easier than you think. I want you to first look at this part. Okay, don't check that. I want you to first look at this property. I want you to look at that property because of the word multiplicity. That's going to be a key point. Now, okay, so probably right now, don't look at the word multiplicity. I first want you to look at this part, that 4 is a 0. Now, when it says 0, 0 is actually just another word for x-intercept. And of course, if your x-intercept is 4, well, you've been finding x-intercepts throughout this entire video. Well, usually you only get an x-intercept if you have a factor with the opposite sign. Or in other words, the factor x minus 4 would give you an x-intercept of positive 4. That's a key thing to remember. But not just that, but our 4 is supposed to be a 0 of multiplicity 1, meaning our power of 1. So with that in mind, I want you to go ahead and write that factor down on the bottom, x minus 4 to the power of 1. That's going to be part of our answer. So with that said, go ahead and put a check next to that property. We've already covered that part. Now, I want you to now take a look at this one. It says negative 4 is the only other 0. Or more specifically, negative 4 is the only other x-intercept. So if we have an x-intercept of negative 4, that means its factor should be the opposite, x plus 4, which of course gives us the x-intercept of negative 4. So how about we take that factor, x plus 4, write that off to the side. That's going to be another part of our answer. So check that off. Now, some of you are probably wondering, Ms. Shulin, cool, we got that negative 4 is the only other x-intercept, which gives us a factor of x plus 4, but it does not tell us what the multiplicity is. Does it have a multiplicity of 1 or 2, 3, 4? What is the multiplicity? Can we just assume it's 1? Some of you are probably thinking that. And I'm here to tell you, do not assume the multiplicity is 1. You're going to find the multiplicity by looking at this property. We want a property, or we want something that gives us a third degree, or a degree of 3. And the only way for that to be possible is if this multiplicity is 2. Because 1 plus 2 gives us a degree of 3. Just like that, 3 properties done. And then your final property, leading coefficient is 3. Leading, basically put 3 in the lead. There you go. You have your leading coefficient. Done. So just like that, you have your final answer. 3 times x minus 4 to the power of 1, x plus 4 to the power of 2. That is your polynomial. The Hawks program may tell you to answer that otherwise, or give you an answer that looks a bit different than that. But don't worry, I have tested this theory, and the Hawks program will accept this answer. If the Hawks program tells you otherwise, come talk to me. I'll explain the issue. But trust me, the Hawks program will accept this answer. Just trust me on that. Got it? Got it? Good. Let's do one more example like that, and then we'll be done for the day. Okay, we are going to construct a polynomial function with the following properties. Fifth degree, 2 is a 0, multiplicity 2, negative 3 is the only other 0, leading coefficient is 2. Let's go ahead and start on this one. 2 is a 0, or more specifically, x-intercept. So if our x-intercept is 2, that means that our factor has to be x minus 2. That's the only way to have an x-intercept of 2. Our multiplicity will also be 2. So just like that, x minus 2 squared, that's going to be part of our answer. Done. Moving on to this property, negative 3 is the only other 0, or the only other x-intercept. So if our x-intercept is negative 3, that means our factor has to be x plus 3. So x plus 3 is going to be the second part of our answer. Doesn't tell us the multiplicity, though. We do not know what the multiplicity is going to be until we look at this property. We need a property of the 5th degree. And the only way to get that is if this multiplicity is 3. So then 2 plus 3 gives us the 5th degree. And last but not least, leading coefficient is 2. Put that 2 in the lead. Done. And there you go, your final answer. 2 times x minus 2 squared times x plus 3 cubed. Type that into the Hawks program. Make sure you don't have any typo errors. Submit. Done. All right, just want to make sure I covered everything. 5th degree, blah, 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 blah. All right, and with that, we are done with 4.4. You are officially ready to start the online homework. Go ahead and get started on that. Get it done. Have a lovely day.